Good. So, good afternoon. My name is Salahuddin Alawadhi, and I'll be giving a short presentation, inshallah, on the optimizing retrieval augmented generation for electrical engineering. So basically, RAG for electrical engineering. Uh, uh, I had a case study done on ABB circuit breakers. So the technical documentation was on ABB circuit breakers. And I would like to thank my mentor and Professor Dr. Noorhan Abbas from School of Computer Science, University of Leeds in UK, as he helped me a lot with this presentation and the paper as well. So moving on, a couple of things that I'll be talking about. First of all, I'll be giving a short introduction on why I thought about this uh, paper in the first place, the research objectives that I want to showcase using this research, background and related work, the methodology I used for coming up with the questions, answers, and uh, everything else. The results and findings that I found from the research, short discussion letters and recommendations and future work. So starting off with introduction, uh, why did I think about this research in particular? I myself, I'm an electrical engineer. I graduated 4 years ago with the bachelor's in electrical engineering. And since then, I've worked in a couple of construction companies, construction and facility maintenance companies as an electrical engineer. So I spent 2 years working as a MEP, so that's mechanical electrical plumbing engineer in a construction company. And after that, right now in my current role, I'm a facility maintenance engineer with more than 2 years experience. And the idea behind this research was during our day-to-day experience in the engineering, we have a lot of documentation that we need to search for and use in case of emergencies and during submission of material submittals to the government or to the client that they have to check. And this can be daunting because documentation for these items are huge and it can be in thousands and thousands of pages and hundreds of thousands of words. So I thought about using RAG to ease the application and see how well it can answer queries from engineers and the client side or the FM side, for example. For example, let me say that we have a short circuit, which is basically a tripping in the electrical side of the system that we're using, so in a house or somewhere else. To find out why this happened, we have to go through documentation on what's the settings for this particular breaker, which could be somewhere within these thousands of pages from the material to submittal. So that could take some time, and using RAG, we can reduce that time and be much more efficient in finding this information to get rid of the short circuit reason and fix the issue. So what are the challenges? It's a high complexity and volume of engineering documentation, as I just said with this example. And we need rapid access to precise, accurate, contextual, relevant data. So this is from the material submittals, and they should be provided by the vendors of such devices. So for example, for circuit breakers, we have a company called ABB. That's the company name. It's not an abbreviation. And so for my work here, I decided to go through using some of the documentation for a certain breaker that they have, which is Emacs 6.2 air circuit breaker. And another challenge is the limitation of general purpose large language models for highly technical tasks. So when using, for example, ChatGPT to find out this information directly without having the particular data about the breaker that I want to use, it becomes much harder as it just keeps guessing or looking for information on the internet that it may not be able to find, as I'm using a very particular uh, set of settings for this breaker that may not be available online and shouldn't be available online, as this is a secured institute and it should not be out there in public, this information, as it could lead, if a cybersecurity attack happened, to damages within this facility. So why RAG? It combines LLMs with external retrieval mechanisms. So we can give it all the data that we have, particular to our site or to our facility, and it can retrieve the data very fast and efficiently, and it can provide us the data that we need in a much easier way. It also offers domain-specific knowledge integration to enhance accuracy and reliability. So it enhances reliability and accuracy through the documentation that we provided, and we can test it as well. So the research objectives are evaluating RAG for technical accuracy, contextual relevance, and factual reliability in electrical engineering tasks. This was done in two ways, quantitative and qualitative. So quantitatively, we used RAGAS, which is Retrieval Augmented Generation Assessment System, which is a much easier way to assess Retrieval Augmented Generation models that we are making, and this is what we used here. And second thing is to investigate optimal combinations of chunking strategies, embeddings, and models. So I didn't just use ChatGPT, for instance. I used a couple of models, such as Cohere, GPT4o, and Claude Sonnet 3.5, I believe. And I used a couple of embeddings, as each of them has his own embeddings, their own embeddings. So ChatGPT has its ADA embedding, and Cohere has its own embedding, as well as Claude has its own embedding that it uses. And I saw the differences in the question answer queries and how it increases or decreases accuracy and other queries. Third of all, identify current limitations and suggest practical improvements. So related work, what is retrieval augmented generation? It's a hybrid approach between retrieval and generative AI models. So it combines LLMs and retrieval, which is much needed here to retrieve the data that we are using, as it's in huge quantities. Also, it improves response accuracy by accessing external knowledge bases, which is our knowledge base that we are using here from the material submittals and documents that we have. Literature review, the main highlights are the advances in embeddings, such as OpenAI, Cohere, and Voyage AI. These are the three embeddings that I use here. OpenAI embeddings, Cohere, and Voyage AI. OpenAI embeddings in ADA embeddings for ChatGPT4o. Cohere embeddings for the Cohere LLM. And Voyage AI is the embedding suggested by Claude, as they don't have their own embedding at the moment, which improves semantic retrieval. For vector database, I use Chroma, which eventually has extensive engineering data. It's much more suited for technical tasks and technical documentations, as we have a lot of PDFs and CSVs and other files that we need to integrate together. And important chunking methods, which were demonstrated in studies such as Sakar and MSc and Cohere et al. And others. So they saw that chunking methodologies can increase accuracy for up to 35% in some cases. This is why we use different chunking methods here. And iterative retrieval approaches. So we used to enhance accuracy and generalization, as noted by medical domain, such as iMedRAC system, also cited in the study. So we use domain-specific dataset. Dataset was ABB circuit breaker manuals. I used 12 documents. The total was almost 907 pages, 100,000 and 130,000 words almost, which is about 537,000 tokens. The data source was technical manuals, guides, specifications in the EMX 1.2 series, sorry, and in the ABB Data Center Solutions manuals. The chunking strategy I use were 3 chunking strategies based on basic chunking, which is simple character limits, minimal semantic considerations. I use paragraph per page, which basically is chunking the paragraphs in each page and putting them in their own chunks, and it ensures page-level contextual coherence. And by title chunking, which is semantic segmentation based on document structure, titles, and headers within each page up to a certain limit. As so far, there is a limit to how many words or tokens a chunk can have. So the embeddings used were Cohere Embed English v3, and this was the latest embedding available for Cohere at the moment. For OpenAI, unfortunately, during the research phase, the embedding I had was text embedding ADA002. After that, a new embedding model has been provided by OpenAI, which I wasn't able to do much research on, unfortunately, but would like to do more in the future. But that's the one I use for now. And Voyage AI for Claude, which is Voyage 3, which was the latest and the best model they have at the moment. The RAG pipelines I use was for the LLMs I use here are Cohere Command X Large Nightly, OpenAI GPT4o, and Anthropic Claude 3.5 Sonnet. As you can see here, these were the best during the time that I was doing the research on this topic. The performance metrics I use in Ragas, as it has a lot more than these four, but the ones I use were faithfulness. Faithfulness basically checks the degree of accuracy between the answer generated from the RAG system and the ground truth that I provide to the LLM system. Context precision, how precise the context is to the retrieved data. Context recall, in the generated answer, how much, how good does it recall the data that it retrieved in the answer it used. And answer relevancy, which basically just measures how relevant is the answer to the context. Results and findings, as you can see here, the context precision for all models were similar. They all had 100% context precision, which is expected. For faithfulness, the Claude paragraph per page chunking method had the best faithfulness degree, which was 85%. Cohere was second with 77.8%, and GPT4o had a similar, almost similar answer ratio, which of about 77.41%. For answer relevancy, GPT4o by title chunking had the best outcomes with 80%, and Cohere had 75%, while Claude had 74%. And context recall, the best was Cohere paragraph per page, second was Claude, and third was GPT4o by title. Here you can see all the results and findings from the different chunking methods for different models. And as you can see here, for GPT4o, I tried the 3 chunking methods: basic, paragraph per page, and by title. And the best answers were all generated by, or the best metrics were all generated by the by title chunking methods, with context precision of 1, faithfulness of 77%, answer relevancy of 0.8, and context recall of 0.69. And for Cohere, it was a bit of a mix-up between 2 paragraph per page and by title, but the best option was the paragraph per page, as it had context precision of 1, faithfulness of 0.778, answer relevancy of 0.7562, and context recall of 0.7705. And for Claude, the best was paragraph per page with context precision of 1, faithfulness of 0.8556, answer relevancy of 0.741, and context recall of 0.6913. And next, I will show you why the qualitative method is as important, or maybe even more important sometimes, than the qualitative method for checking the answers. Here, I give one example. I give 3 examples. We'll start with the first one, which is activating terminating resistance. So the question asked to the LLMs, to the RAG model, was how to activate the terminating resistance on the EKIP Modbus RTU model. So you have to be an expert in this field to understand this question and how to answer it. So the ground truth from the ABB manual, if you had time to search for it, would be to enable the R term. The corresponding diff switches 1 and 2 must be positioned to on. A diff switch is basically a switch that goes to 0 and 1, and we have almost 6 or 7 diff switches on each ACB, maybe even more sometimes, depending on the breaker size. And in this one, we had only to have 2 on, which is diff switch 1 and 2. So I check the models and their key strengths in answering the key issues, and I give them the verdict on how accurate and cautious the answer it gave is. So for Claude, it gave step-by-step explanation with practical network use case context and avoid speculation, which is what we need in this case, as any speculation can lead to a disaster by providing the wrong diff switch position and setting the ACB or the circuit breaker on wrong settings that could lead to disaster in the future. The key issues noted was that the specific switch may vary, promoting caution. So there could be more than one dip switch on the ACB itself. So you had to be careful on which dip switch to operate. The final verdict was that it's accurate and cautious. So it's a very good answer. For GPT4o, it explains the purpose, when to activate, and cites ABB documentation. The key issue was that it doesn't specify dip switch numbers, and it's slightly repetitive. So it's accurate but general, and you cannot use the answer it gave you to correctly enable the terminating resistance. And for Cohere, it describes the switch roles and how configuration works. It offers general advice, but no specific details about the R-term switching. So it's vague, but factually safe, but it doesn't give you the answer that you need, which isn't very useful in this case. Why does this matter? This example shows how models can vary in specificity while avoiding outright hallucination. See, as Claude and GPT4o both provide helpful answers without making up raw technical details. Cohere avoids risk but lacks actionable details. Moving on to the second example, trip unit capabilities in the Emacs2 category. So the question I used here was, what features and functionalities do the SAS Emacs2 function trip units offer? The ground truth being protection trip units include overcurrent protection, diagnostics, energy metering, and communication. C. Claude listed advanced features, including residual current diagnostic and metering. No key issues found. It had strong answers, and it was domain aligned, so that it was very well aligned with the ground truth. For ChatGPT4o, it had a very clear structure, bullet style, and covers protection, diagnostics, and communications. It had slightly generic metering types, but was clear and relevant. For Cohere, it had broad language, advanced trip units, but lacks mentions of specific features. It's overgeneralized, no reference to metering or communications. It was way too general and lacking detail. It was not usable in this use case as well. Why this matters? This question tests how well a model extracts and communicates core functionality specs. Claude and ChatGPT do well, while Cohere leans towards marketing style vagueness, which is not acceptable in this scenario. The third and last questions that I use an example here, which what are the features and functionalities of the residual current protection in Emacs2? These are all questions that are heavily related to electrical engineering, which I used. And the ground truth was that two configurations exist, one with an external transformer and one integrated, both configurable via trip unit settings. So Claude correctly differentiates between external and integrated versions and displays settings, and it had no key issues notable. It was fully grounded to the ground truth. Excellent answer. However, ChatGPT4o discusses protection and the current and explains important, but doesn't distinguish between two versions, which is accurate but lacks nuisance. For Cohere, it talks about general circuit protection features, but fails to mention residual current transformer configuration, which is not specific enough. And this is a great example of why faithfulness generation is essential. Even when answers are correct in tone, missing key configuration distinctions like transformer types can lead to incorrect installations or diagnostics in real-world systems. So coming up to the end here. This demonstrates potential and limitations of retrieval augmented generations for critical engineering tasks. And the precision shown here, about 80%, is insufficient. Error in this domain can have severe consequences, and it's not acceptable to be 80% precise here. And the challenges identified were retrieval inaccuracies due to suboptimal chunking or embeddings, and this can be solved using other embeddings and other chunking methods. It had limits in current model architecture and retrieval strategies. And ethical considerations to take to consideration are importance of transparency and explainability in AI-generated technical recommendations, as this can lead to wrong settings in the equipment itself, which can lead to trouble in the future. And it needs rigorous validation due to high stakes of electrical engineering applications. So the recommendation and future work, I would like to combine by title and paragraph per page strategies for the chunking methods and enhance retrieval method by using multi-stage retrieval, so iterative query expansion, or re-ranking techniques to enhance precision in such as Cohere and OpenAI re-rank models. And in the future as well, use maybe knowledge graphs to integrate semantic search, fast verification, and structure relationships such as IAC standards and breaker specs. Also, use multimodal data integration, such as business transformer for schematics, table parsing methods, deep table, tabas for structured data extraction, and extending methodology to other engineering domains and breaker models to further test the RAG capabilities. In conclusion, I evaluated and analyzed RAG for ABB circuit breakers, established optimal configuration at the moment, which is Claude paragraph per page chunking methods, and identify critical gaps, going target improvement for future versions. Develop a robust, reliable RAG systems with enhanced retrieval and multimodal capabilities to include pictures and graphs in the model, and prioritize transparent ethical deployment in engineering settings. Thank you. That was all. If anyone has any questions, would be more than